radius somehow, as in this case. You must understand that the radius is always perpendicular to the tangent. So in other words, the angle between the radius and the tangent is always 90 degrees. Okay, this is always the case. One thing to note that the radius is always perpendicular to the tangent. So radius perpendicular to the tangent. Okay. And then now let's talk about how can we determine the equation of a tangent, that is a tangent to a circle. Okay, so let's call this AB, and then let's call the radius, let's say the center is O, and then the point of intersection is C. Okay, the aim or the goal is for us to determine the equation of AB, or the equation of the tangent. Equation of tangent AB. Okay, now we can all agree that the tangent or the line AB is a straight line. So therefore we know that the equation of a straight line will have the form of y is equal to mx plus c. So we need to figure out the gradient and then take it from there. Now, one thing that we need to note is that OC, which is the radius, is perpendicular to, let me just write this, OC is perpendicular to AB, right? Perpendicular to the tangent AB. And we know something about the gradients of two perpendicular lines. In our previous session, we said that if two lines are perpendicular, then they have inverse gradients. In other words, gradient of one line times the gradient of the other line will give us a value of -1. Okay, they have inverse gradients. This is what that means. Okay, so we would use this relationship to get the gradient of AB. So basically what we'll do is we'll get the gradient of OC, which is the gradient of the radius, and then we can use this equation to get the gradient of AB. Let's do that. So the gradient of OC is y2 minus y1 over x2 minus x1. Okay, now y2 minus y1 is what? Let's say I choose to call this point 1 and then this one point 2. So it will be 2 minus 5, and then it will be 3 minus 2. Okay.
Hey there, please note that this was just a portion of the actual session. You can find the complete session on our YouTube channel. I have attached the link to the channel on the comment section. Go check it out. Don't forget to like, share, and follow us on all social media platforms. See you on the next